Hi, what's up? Today I want to talk about another very interesting question that is designed to test your understanding of recursion. The name of the question is called climbing stairs, and the question goes like this. You are climbing a staircase. It takes n steps to reach to the top. Each time you can either climb 1 or 2 steps. In how many distinct ways can you climb to the top? So let's put this question into examples. When we have only 1 step between our floor to the top, obvious answer should be climb 1 step and that's it. And output should be 1. When we have 2 steps between the floor and the top, we can either climb 1 step per time or climb 2 steps per once, and the output should be 2. And when the input is 3, we can either climb 1 step per time or climb once 2 steps and once 1 times, or climb once 1 step, then climb once 2 steps. Then we can also get to the top. So there will be 3 distinct ways we can get to the top. The output should be 3. The obvious answer should be write a function here and passing in, and immediately we return the output of immediately invoked function called clamp, and it's going to take in a parameter called current step. Alright, and let's initialize the function with a base layer parameter, and it's going to be floor. Alright, and then what we can do is check if our current step is bigger than n, then we have missed our so that approach did not go well, so we return 0. And if our current step is equals to n, means that we have find ourselves a good solution, a distinct way, so we return 1. And else should be when current step is smaller than n, so in that case we just return what happens when climb what happens when we continue climb one step, or what happens when we continue climb for 2 steps, and this should be output our result correctly. But this is not a good solution because we didn't include memorization. So when we do something like this, you can see from using the same example, we are recalculating many parameters multiple times, and if the input parameter goes in as a pretty large value, the algorithm probably is going to keep running and never give you the result. That's exaggeration, but it's just going to use a lot of time. So we need to use memorization, and you can include it in here and declare a new map as an initial value. And first step would be check. So check if our memo has this key called current step. If that's the case, we just need to return our value at this key inside the memo. So current step. And if we never met this condition, memo doesn't have this current step, then we need to set this current step as the key inside our memo. So set takes in the key first. The key should be current step, and the value should be this. And then we should pass in the memo as well. Okay, so then we just need to return, don't recalculate the climb twice, so we just need to return get current step, because we just pushed it, so there's no need to recheck if we has this key anymore. So let's retest our solution. Almost immediately we got our solution. Alright, So let's discuss the other solution. All right, and the other solution goes like this. It takes about a minute to understand. So step 3 can be can be reached from 2 instances. So it can be reached from step 2 and by clamp once. Okay, not once, one step. Okay, or it can be reached from step 1 by clamp 2 steps. All right. So to calculate the sum of distinct ways to get to step 3, we just need to have the sum of distinct ways to get to step 2 and sum of distinct ways to get to step 1, and we plus them together. Then we know that once we reach step 2, there would be just one scenario to get to step 3, and so does step 1. So we just need these two. So to put this in another way, it should be climb stairs 3 should be equals to climb stairs 2 climb stairs 1. Okay, once you understand this concept, you can easily write a lot of different ways then to get to the climb stairs 3. And one solution of them is just build an array from 0 to n and return that array at the index of n. Let's do just that. So same name here. So first we initialize some base case. So if n is equals to 1 or n is okay, not that case, return 1. Okay, some base case should do just fine because we need n minus 1 and minus 2, right? So then we declare our array should be counting okay, this is probably too long name, count array should do. Alright, it should be a new array of size n plus 1. Okay, then we just initialize the array at index and 1 to be equals to our 1 here, and 2 should be equals to 2. Then on the for loop, let index equals to 3 first, I should smaller or equals to n, and add plus plus. Okay, then we can do our sum by having count array as index of 3 equals to, okay, not 3, I should equals to count array at index of I minus 2, 1 first, or count array is I minus 2. Okay, in the end, we just need to return our count array at index of n. Same value, we have obtained the same answer. So for the space complexity and runtime complexity between these two solutions is pretty similar when testing lead code. And yeah, that's the two ways we can use recursion to solve the problem of climb stairs. Thank you for watching this video and have a good day.